Let's review 4 methods besides the cause and effect or fishbone diagram for conducting a root cause analysis. Sometimes the cause and effect diagram gets us what we want, but sometimes these other 4 approaches are complementary or more helpful, and they are the 5 whys, the is or is not comparison, the fault tree analysis, and the failure mode and effects analysis. And the good news is I think they're as simple as the cause and effect diagram. So let's just go ahead and look at them here. The 5 whys is very similar to the cause and effect diagram, and you can tell that by the way it looks. And the way it works is you just ask the why question, or sometimes how or what, as many times as it takes to identify a root cause. And sometimes you ask this question 5 times. It is called the 5 whys analysis, but sometimes you get the root cause that you, after asking the question 4 times, sometimes it takes 20 times. And sometimes you get the question of when can we stop asking why? And generally the idea is you stop asking the why question when you find a person, a policy, or a process that you can actually take corrective action or preventive action and apply it. So let's look at an example, and this is from an article I found in Quality of Progress magazine. So let's say you got caught speeding. You got a speeding ticket. And we could ask the question, why did you get a speeding ticket? Well, maybe you were late for work and that's why you were driving too fast. And then we could ask the question, why were you late for work? Well, maybe you got up late. Why did you get up late? Your alarm clock didn't work. Why did your alarm clock not work? Well, the batteries were dead. Why were the batteries dead? Because you forgot to replace them. So here you can see the corrective action is to either get a plug-in alarm clock that plugs into the electricity, or replace the batteries at specific intervals of time so that the alarm clock doesn't run out of batteries. So there you can see an example of asking the why question, let's see, 1, 2, 3, 4, 5 times until we found a root cause that you can actually do something about. Okay? Pretty simple. The next one is called the fault tree analysis, and this is another top-down approach where you start off with the key quality problem, and here we used a deductive reasoning procedure for determining whether combinations of root causes will result in a pattern. And so you need to get familiar with these symbols here. And really, sometimes, think of it this way, you might have a problem that can occur independently, or maybe a problem that the root cause needs another root cause to happen in order to work. So, and that's what these pictures are for, is in this case, if input A and input B are true, then the output is true. If input A is true, but input B is false, then the entire output is false. And same thing, if input A is false, it needs an input B is true, then the output is false. If both of them are false, then the output is false. Look how it's different here for the OR gate. If A or B is true, then the output is true. Okay, is it clear as mud? Maybe. So let's look at an example to see it applied in action. Okay, so here we go. Figure 1. So if you have something that could cause a hazard to a patient, well, it could become a vacuum to the bloodstream, or it could cause blood damage, or it could cause electrical shock. For it to occur to cause electrical shock, then the patient would have to be grounded and the pathway would have to run to the source. So see how both of those have to happen in order for it to have electrical shock. So that's the way fault tree analysis works, and we'll look at a case study in food processing that applies fault tree analysis later in the course. Okay, the next one is the is or is not analysis, and okay, the next one is the is or is not analysis, and this is also helpful for distinguishing when a problem occurs and when it doesn't occur, or where it occurs and where it does not occur, what occurs and what does not occur. So if you look at these specific questions, what specific object has the defect? And then you can ask, what similar objects could have the defect but don't? So it's just a real simple way of saying, is it this and what is it not? Is the problem here? Where is the problem not? Because that allows you to distinguish through all of the possible causes that you might have put on a cause and effect diagram, for example, and you can distinguish, well, it's not this one, and you can start crossing them off the cause and effect diagram. Okay, and the last one is the failure, mode, and effects analysis. And we looked at this one earlier in the course with the case study with the bakery. And this one is nice, and actually all of these are nice for when you don't have access to the data you need, but you can kind of guess your way through what the root cause would be. And the idea is that you identify the function that is supposed to occur without error. And you then identify how that function could fail. So here we're looking at a cash register that dispenses cash requested by a customer. And the potential failure modes are that it either does not dispense cash or it dispenses too much cash. Wouldn't that be great if you're the customer? Or it takes too long to dispense the cash. For each one of these failure modes, you identify the effects of that failure. So if it doesn't dispense cash, then the customer is going to be very dissatisfied. And you'll have an incorrect entry to demand deposit system, and there will be a discrepancy in cash balancing. So there's multiple effects for this one failure mode. And for each one of these effects, we identify for this failure, we identify, and it looks like this is on a 9-point scale, how severe that would be. And for each of these potential effects, we identify the potential cause. So it could be out of cash, or the machine might jam, or there might be a power failure during transaction. For each of those, the O stands for a relative level of occurrence. How often could this happen? And so here's a 5 on a 9-point scale, with 9 being the highest level of occurrence. And then we also identify the current process controls. So you could have an internal low cash alert for when it comes out of cash. And the D stands for how well can you detect the problem. And notice how if you multiply 8 times 5 times 5, you get 200. 8 times 5 is 40, times 5 is 200. This is the risk priority number. And you can use this to rank the relative amount and get an idea of which ones to take action on first. But keep in mind, if one of the things people don't realize is if you had a 200 here, but let's say this one was, instead of 8, 5, and 5, maybe it was 5, 8, and 5, and they both equaled 200, then you could look at it and say, which one do I want to address first? One has a severity ranking of 8, the other one has a severity ranking of 5. One has a probability of occurrence of 8, the other one has a probability of occurrence of 5. So there's just that catch there. So anyway, that's the 4 root cause analysis methodologies that that you can use in addition to the cause and effect or fishbone diagram or Ishikawa diagram. So now you should have 5 root cause analysis tools in your arsenal.